A stellar spectacle, the life and times of a star. Have you ever looked up at the night sky and wondered about the twinkling stars? Those tiny points of light that seem so distant and mysterious? They have fascinated humanity for millennia, inspiring countless myths, stories, and scientific inquiries. But what are these stars, really? Each tiny point of light is a giant ball of burning gas, primarily hydrogen and helium, undergoing nuclear fusion in its core. This fusion process releases an immense amount of energy, which is what makes the star shine so brightly. These stars, much like us, experience a life cycle filled with drama, transformation, and ultimately, a grand finale. From their fiery birth to their spectacular death, the journey of a star is a tale of cosmic evolution. From their birth in cosmic clouds known as nebulae, to their explosive deaths in supernovae, the lives of stars are a captivating story of cosmic proportions. These events are not just random occurrences, they are essential processes that shape the universe. Imagine a star's life as a grand play, with the universe as its stage. Each star is an actor playing its part in the grand cosmic drama. The stage is set in a vast dark nebula, a region filled with gas and dust. This is where the story begins. The curtains rise on a cloud of gas and dust, the raw materials for our stellar protagonist. These clouds are often the remnants of previous stars that have ended their life cycles. Gravity plays the role of director, pulling this material together. As the gas and dust clump together, they form a protostar, the first stage in a star's life. As the cloud collapses, it spins and heats up, setting the stage for a star's dramatic entrance. The temperature and pressure in the core of the protostar increase until nuclear fusion ignites, and a new star is born. The life cycle of a star is a tale of immense energy, incredible transformations, and eventual demise. Stars spend most of their lives in a stable phase called the main sequence, where they steadily burn hydrogen into helium. But even in death, stars leave behind a legacy that enriches the cosmos and contributes to the formation of new generations of stars and planets. When a star exhausts its nuclear fuel, it undergoes a dramatic transformation, often ending in a supernova explosion. This explosion disperses elements into space, seeding future star systems. So the next time you gaze at the night sky, remember that you are witnessing a cosmic ballet of life and death, creation and destruction, all playing out on a celestial stage. Each star you see has its own story, a unique journey through the cosmos, contributing to the ever-evolving tapestry of the universe. Stellar nurseries, where stars are born. Stars aren't just scattered randomly across the universe, they are born in vast clouds of gas and dust called nebulae. Think of these nebulae as giant cosmic kitchens, filled with the ingredients needed to bake up a star. These clouds, mostly composed of hydrogen and helium, are spread out over unimaginable distances. Gravity, the master chef in this cosmic kitchen, gradually pulls these ingredients together. As more and more material clumps together, the cloud's core begins to heat up under the immense pressure. This hot, dense core is called a protostar. It's not quite a star yet, but it's well on its way. The protostar continues to gather material from the surrounding cloud, growing hotter and denser. Eventually, the temperature and pressure at its core become so intense that nuclear fusion ignites. This is the moment a star is truly born. The main event, a star's prime time. Once nuclear fusion begins, a star enters the longest and most stable period of its life, the main sequence. This phase is characterized by the star fusing hydrogen into helium in its core, releasing an immense amount of energy that radiates outward. Our very own Sun is a perfect example of a star in its main sequence. It is a G-type main sequence star, also known as a yellow dwarf. It has been shining brightly for about 4.6 billion years, and astronomers estimate it has another 5 billion years to go. This means our Sun is roughly halfway through its main sequence phase. During the main sequence, a star is in a constant state of equilibrium. This balance is crucial for the star's stability and longevity. The outward pressure from nuclear fusion in its core perfectly balances the inward pull of its own gravity. This delicate balance ensures that the star does not collapse under its own weight or explode outward. This balance is what allows a star to shine steadily for millions or even billions of years. The energy produced in the core travels outward, eventually reaching the surface and radiating into space as light and heat. The color and brightness of a main sequence star depend on its mass. Stars come in a variety of masses which directly influence their temperature and luminosity. More massive stars burn hotter and brighter, emitting bluish-white light. These stars have shorter lifespans because they consume their nuclear fuel more rapidly. Smaller stars are cooler and dimmer, emitting reddish light. These stars, often called red dwarfs, can burn for tens to hundreds of billions of years due to their efficient fuel consumption. Our Sun falls somewhere in between, shining with a yellowish-white hue. This color indicates a moderate temperature and a stable, long-lasting main sequence phase. The Sun's balanced characteristics make it an ideal star for supporting life on Earth. The diversity of main sequence stars in the galaxy is astounding. From the smallest red dwarfs to the largest blue giants, each star plays a unique role in the cosmic tapestry. Understanding these stars helps us learn more about the universe and our place within it. As we continue to explore the stars, we uncover the secrets of their formation, evolution, and eventual fate. Each discovery brings us closer to understanding the intricate dance of the cosmos. Stellar variety, a universe of different stars. Not all stars are created equal. Each star in the universe is a unique entity, with its own set of characteristics that define its life cycle and ultimate fate. The universe is teeming with a diverse array of stars, each with its own unique characteristics and life story. From the smallest red dwarfs to the largest supergiants, the variety is truly astounding. Some stars, like our Sun, are average-sized and live relatively long lives. These stars, known as main sequence stars, spend the majority of their lives fusing hydrogen into helium in their cores. Others are massive and burn brightly for a short time before exploding in a spectacular supernova. These massive stars, often called supergiants, have much shorter lifespans due to their rapid consumption of nuclear fuel. Then there are the small and faint red dwarfs, the most common type of star in the Milky Way galaxy. Despite their small size, red dwarfs are incredibly numerous, and make up the majority of stars in our galaxy. These stars are much cooler and less massive than our Sun. Their lower temperatures mean they shine with a dim reddish light, often making them difficult to observe without powerful telescopes. They sip their hydrogen fuel slowly, allowing them to live for trillions of years. This slow consumption rate means that red dwarfs can outlive many other types of stars by a significant margin. Massive stars, on the other hand, live fast and die young. Their immense size and high temperatures lead to a rapid fusion process, which shortens their lifespans dramatically. These stellar giants consume their fuel at an astonishing rate, leading to incredibly high temperatures and pressures in their cores. This intense environment allows for the creation of heavier elements through nuclear fusion. This allows them to forge heavier elements like carbon, oxygen, and even iron. These elements are crucial for the formation of planets and life as we know it, but their reign is short-lived, ending in a spectacular supernova explosion. This dramatic event scatters the heavy elements forged in the star's core into space, seeding the cosmos with the building blocks for new stars and planets.